Nice launch trajectory and countdown net. Pad is clear.
10, 9, 8.
Launch auto sequence has started.
6, 5, 4, 3, 2, 1.
Go for launch.
Vehicle is supersonic.
Stage separation confirmed. Dragon, separation confirmed. Stage 1 is transonic. Landing legs have deployed. And Falcon 9 has landed.
Good afternoon and welcome to our Starlink webcast. Our launch today marks SpaceX's 20th launch of the year and the 47th Starlink mission overall. Now, if you've been following along, you'll know that this is our second Starlink launch in under 24 hours. We lifted off from our West Coast launch pad yesterday, and today we'll follow Falcon 9's ascent from Launch Complex 40 at Cape Canaveral Space Force Station in Florida. Thanks for tuning in. My name is Shiva Bharadwaj. I'm a space operations engineer, and I'll be your host for today's flight. Now, for those of you that are new to our webcast, Starlink is a satellite internet constellation designed and manufactured by SpaceX. It provides high-speed, low-latency internet to people living in remote and rural locations around the globe. The rocket on your screen today will be taking another 53 Starlink satellites into low Earth orbit, which is also known as LEO. Now, on your screen, you might have noticed a fresh coat of paint on this rocket, and that's because unlike most of our previous Starlink missions, we'll be flying a brand new booster this afternoon. It's also worth noting that we will be ending live coverage after this first stage returns to Earth and after second stage engine cutoff, so please keep an eye out on our social channels for confirmation of payload deployment. We'll also leave the mission audio live on our YouTube channel if you'd like to follow along through payload deployment there. Now, for some reason, if we don't launch today, we do have a backup opportunity tomorrow, Sunday, May 15th at 4:12 p.m. Eastern Time. The vehicle on your screen is our Falcon 9 rocket. It's located at Space Launch Complex 40. We prepped this Falcon 9 for launch in our hangar located at the base of the pad, and upon completing final checkouts, rolled it out with the Starlink payload going vertical about 15 hours before liftoff. Pad 40, or Launch Complex 40, is located in Florida at the north end of Cape Canaveral Space Force Station. Now, before SpaceX, that Pad 40 was owned by the United States Air Force and used to launch Titan vehicles from the mid-1960s through Titan's retirement in about 2005. Pad 40 was then leased to SpaceX to support Falcon launches in 2007, and since then we've supported 85 launches from the pad, today marking number 86. Now, as for the rocket, starting from the bottom, we've got the first stage. It's the largest part of the vehicle and responsible for bringing it out of the Earth's atmosphere for repeated trips to space. To date, we've flown 96 flight-proven boosters on numerous missions, but as I mentioned earlier, the booster supporting today's mission is brand new. Now, above the first stage, we have the second stage, connected by an inner stage. The inner stage houses the Merlin vacuum engine, which is connected to the bottom of the second stage. Although very similar to the 9 Merlin 1D engines at the base of the first stage, the Merlin vacuum engine has a much larger nozzle, and that allows the second stage to perform better in the vacuum of space. You might also notice that the second stage resembles the first stage quite a bit. Not only does it look similar, it also has the same diameter, uses the same metal in the tanks, the same computers, the same propellant, and nearly the same engine. This allows us to use similar tooling, design, and systems to essentially build 2 rockets that are more reliable. At the very top of the rocket, we have the payload fairing. The fairing is composed of 2 composite structures. They come together to protect the Starlink satellites until we reach the vacuum of space. Once we get to second engine cutoff, we'll separate the fairing halves and jettison them back to Earth and attempt to retrieve them. Both of the fairing halves protecting our Starlink satellites will be flying for their second time. Following separation from the second stage, we will also be attempting to recover the first stage for its first time on our drone ship named Just Read the Instructions, which is stationed out in the Atlantic Ocean. If we're successful, it'll mark our 120th overall recovery of a Falcon first stage. beautiful day at the Cape today. We're monitoring some weather earlier, but the weather has continued to get better and better, looking towards 80 to 90% chance of go weather. But for some reason we don't lift off today, we will have a backup opportunity tomorrow, May 15th at 4:12 p.m. Eastern Time. We've got a view of the payload fairing and the second stage, and you can see that the clamp arms on the transporter erector have just started to open. The transporter erector is that truss structure you see to the left of the vehicle. Now, the transporter erector was used to roll the Falcon 9 out to the pad and raise it to this vertical launch position. And it also routes the vehicle's fluids, power, and telemetry between the ground systems and both the rockets and the satellite. Shortly here, we'll see the transporter erector retracting away from the vehicle. You can see it on the left-hand side. This is in preparation for launch. Now, as I mentioned before, this is our second Starlink launch in less than 24 hours. So this weekend, we'll put up just over 100 Starlink satellites to support our growing network. We launch our Starlink satellites into low Earth orbit, both because it's the most responsible thing to do for keeping space clean, but also because it results in better service. We use super advanced satellites in a low Earth orbit, and because of that, Starlink can support video calls, online gaming, streaming, and other high data rate activities that historically haven't been possible with satellite internet. The team is also rapidly expanding areas where we can offer service, as you can see on our new availability map. And one of the biggest hurdles to providing service in many countries is regulatory approval. So we're continuing to push hard for that, and our hope is that we can turn on service for a lot more people in the near future. If you'd like to check out our current service areas for yourself, head on over to our website at starlink.com/map. Now, you just heard a call out for LOX loading complete on the first stage. We used 2 propellants on Falcon 9, liquid oxygen and RP1, rocket propellant 1. Coming up next, we'll hear a similar call out for the second stage on the vehicle for LOX loading complete. That expected around T+2 minutes. Following that, the transporter erector, which I talked about earlier, which routes those fuel and oxidizer to the vehicle, will conduct some venting as we clear out the lines in preparation for launch. And you can see a little bit of that clouds forming around the vehicle. That's because the tanks are pretty cold right now with that cold, super chilled liquid oxygen.
Stage 2 LOX load is complete.
Which we just finished loading on the second stage. And so you're seeing the moist Florida air forming literal clouds as it condenses around the vehicle.
Ground gas closeouts.
With that call out for ground glass closeouts, we've vented the lines in the transporter erector that's causing that big plume of cloud you see right next to the vehicle. Coming up next, about 15 seconds, Falcon 9 will transition into startup. From there, the first and second stages will begin to pressurize for flight, and the vehicle will be autonomous for the rest of the launch. And looking like a clear, beautiful day at Florida for an on-time liftoff.
Falcon 9 is in startup.
So with that call out, Falcon 9 is autonomous through the rest of the launch. Launch director will give their final go for launch up next.
Starlink 415, LD, go for launch.
So with that, the LD, or launch director, giving their final go for launch. We're just over 30 seconds to go. Range green, weather green, Falcon looking healthy. With just 30 seconds to go, let's watch Falcon take 53 Starlinks to low Earth orbit.
T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. And liftoff. Go Falcon, go Starlink.
Falcon is switching downrange. M1D chamber pressures are nominal.
Successful liftoff of Falcon 9 from Space Launch Complex in Florida, bringing 53 Starlink satellites into orbit. This first stage lifting off for its first time. Now, although at liftoff, gravity is pulling straight down on the rocket, as we ascend, we tilt the engines. That's called gimbaling, and we begin to turn the rocket horizontally. So we're still going up, but we're starting to pick up sideways speed away from the pad. This is called a gravity turn. So this is what we use to get ourselves into orbit. Coming up next, we'll expect a call out for maximum dynamic pressure, or max Q.
Maximum aerodynamic pressure.
So max Q being the point where the stresses are highest on the vehicle. We're speeding up, the atmosphere is getting less dense, and so there's a point of maximum pressure on the vehicle. So now that we're through that, it should be easier and easier for Falcon to get into orbit. Now we've got 3 events coming up about a minute from now. The first of those being main engine cutoff,
MVAC engine chill,
or MECO. That's where we'll shut down all 9 of the Merlin 1D engines in preparation for the next event, which is stage separation, where the first and second stages will separate from one another. First stage continuing back towards planet Earth for recovery, and the second stage continuing on to that third event, second engine start number 1.
Nominal.
We heard a call out for engine chill beginning on the Merlin vacuum engine that's prepping the turbo pump on the Merlin vacuum in preparation for full propellant flow. Shortly after second engine start of the Merlin vacuum, we'll also have fairing deployment. And once we're in the vacuum of space, we don't need to carry those fairing halves anymore, and we'll bring them back to planet Earth for recovery. So coming up, MECO, stage SEP, SES-1.
Main engine cutoff. Stage separation confirmed. MVAC ignition. Separation confirmed.
Awesome. So those 4 events happening. Maybe we'll get an extra shot of those fairing halves heading back to planet Earth. You can see on the right-hand side of your screen, well, there's the Merlin vacuum and a fairing half. Left-hand side, you can see the first stage is deploying its grid fins with an amazing view of our planet behind it. And we also saw a view earlier of those Starlink satellites getting to see the vacuum of space for the first time. Now, the next major events will happen about 3 minutes from now. They'll happen on the first stage, which is on the left-hand side of your screen. That'll be entry burn on the first stage. And so during the entry burn, we'll ignite 3 of the Merlin 1D engines as we start to get to the thicker parts of the Earth's atmosphere. And that reduces the loads and the heating on the first stage as we start to re-enter the atmosphere, making it easier for us to recover the vehicle. You're seeing periodic bursts of white gas on the vehicle, like there. That is from our attitude control system
signal, Bermuda.
on the first stage. So we carry nitrogen gas. And because there's no air, or very limited air, I should say, in the vacuum of space, the attitude control gas is what's giving us force to change the orientation and get the engines pointed down. Those grid fin structures, you see 2 of them on your screen on the left-hand side, can't do much with the vacuum of space. So we have to use the attitude control thrusters to orient the engines down. Right-hand side of your screen, you can see the orange glow of our Merlin vacuum engine on the second stage. It'll continue burning until about T plus 8 minutes, 50 seconds or so. It's got a long burn ahead of it to take those 53 Starlink satellites into orbit.
Both stages are on nominal trajectories.
With that call out there, we're hearing from the ground team that both the stages are right where we expect them to be. As a reminder, the first stage is heading to our drone ship named Just Read the Instructions, which is stationed out in the Atlantic Ocean. It's changing its orientation so we can get the engines pointed down for the upcoming entry burn, where we'll ignite 3 Merlin engines. That burn will last about 20 seconds. And that's to slow down the stage in preparation for gliding through the Earth's atmosphere. As we start to pick up density in the Earth's atmosphere, those grid fins becoming more and more effective in controlling the flight path of the booster towards our drone ship. Once we get to the drone ship, just above it, we'll have another burn. That'll be the landing burn, where we'll ignite just 1 Merlin engine, the center Merlin engine. Then we'll deploy the landing legs and hopefully have a soft touchdown on just read the instructions. Second stage burn, continuing to look nominal, taking 53 Starlink satellites into orbit. Now, if you're just joining us, you came at a good time. We're coming up on entry burn on the left-hand side of your screen.
Stage 1 FTS has saved.
Stage 1 entry burn startup.
So nominal start of the entry burn. We're flying through our plume, so we use a carbon-based propellant, hydrocarbon-based propellant, and so that's actually what causes the soot to appear on our reflown boosters.
Stage 1 entry burn shutdown.
This burn lasting just about 20 seconds, just enough to slow us down as we start getting into the thicker parts of the atmosphere. And from here on, you'll see more action from the grid fins. They'll rotate a little bit to keep the stage on track towards our drone ship. Next major event coming up on the first stage, that'll be the landing burn at about T+8 minutes, about a minute from now.
Stage 1 trajectory nominal.
That burn lasting about 20 seconds. As we briefly lose the video feed there on the first stage, coming back to a view of the second stage. Now, it's been burning since stage separation, about 2.5 minutes into flight. And it'll continue its burn for about another minute,
Stage 1 is transonic.
15 seconds. Targeting shutdown just around T plus 8 minutes, 50 seconds, 9 minutes into flight. Here we go, exciting view from the first stage. We'll expect to see entry burn startup, or excuse me, landing burn startup here.
Stage 1 landing burn.
So there's ignition of the center Merlin engine. You can see the grid fins helping guide us towards the drone ship. And we'll expect to see the landing legs deploy just before we touch down.
Stage 2 terminal guidance.
You can see that our speed is rapidly coming down to 0. There's landing leg deploy. Oh, and a lovely touchdown.
Stage 1 landing is confirmed.
This booster's first landing, the 111th recovery of a Falcon 9 first stage booster, for many more flights to come.
FTS is saved.
Coming up, second stage, coming to its its next activity, second engine cutoff number 1. And the ground teams will then assess the orbital trajectory and give us a call out if we're right where we intended to be.
Second engine cutoff.
So successful shutdown of the Merlin vacuum engine.
Expected loss of signal tape.
And a beautiful view of our
Nominal parking orbit.
With that call out for nominal parking orbit, that means the second stage is safely in orbit. Awesome shot of the first stage on your screen for its first landing. And with that, we're actually going to be ending our webcast for today's launch. As I mentioned previously, we will be confirming payload deployment over our social channels, so keep an eye out for that. That's expected around T+54 minutes into flight. We'll also leave the mission audio live on our YouTube channel if you'd like to follow along there through payload deploy. Big thanks to the Federal Aviation Administration for supporting our mission. Of course, thank you to our viewers and to all of our Starlink customers for using the service at this time. That's been a pretty busy set of few days here at SpaceX. We want to thank you for joining us this Saturday, and we hope you all have a fantastic weekend.